Since the beginning of time, I can imagine Adam and Eve sitting there with the wind blowing across their face, and they had some of that vines on. Probably would have been pretty interesting. Snake coming along, then they bited apple, and then came sin. Then came knowledge of wind, power to stoke fires with. They used it for cooling, stoke fires, like I said. And then they learned to sail boats in Persia, in the Persian Sea. It was Iranian, it's where Iran is now, around 1200 BC, or AD, something like that. Somewhere right in there. And then after then it's not working.
The one on the right. There you go.
And this is an old wind turbine that was built in America in the 1888, matter of fact, by Charles Brush. And it produced 12,500 kilowatts or megawatts, something like that. And Charles Brush, he was a Dutch engineer, and his turbine led us up to today's present turbines. For without him, I'm sure the wind technicians of today and the wind turbines wouldn't be here. He was a great inventor, and he was pretty awesome. This is an actual blade cutaway view of the blades of the wind turbine. They're made out of fiberglass and wood and resin, the majority of them. They're approximately on a G 1.5, they're about 150 feet long, and on 3.5, they're a little more than that, they're about 175, maybe 200. This is a wind turbine being erected. That's awful high. That one there in particular is 126 meters, which converts out to, I think it's 483.13 feet, once the Nelsus is on top of it. The wind turbine works basically like this. It's like a great big blade in air. You got three blades. They started out a single blade, then they went to a dual blade. They started out a vertical axis, like a kite, but tighter in and wrapped. What happens is the wind starts the blade to turning at about 8 miles an hour. And the blade is connected to a low-speed shaft. And that low-speed shaft runs into a gearbox, which is basically your transmission on a car. And at the other end of the gearbox is another output shaft. It's an output shaft that's a high speed. And it's around, what, I think 4,800 to 7,800 RPMs per minute, the high-speed shaft, which in turn is connected to the armature on your generator, which turns the armature at a very high rate of speed, and as the law predicts, opposites will attract the north and south pole and create electricity. Then it runs down through the wiring of this tower. Can I back that up?
Left button.
It runs back down through the wire of this tower here that you actually climb inside of. Runs back down through here to a pad mount transformer or a substation. Through the transmission lines, the distribution lines, and then to the ultimate person, the end user, the consumer, the customer, which pays for all that fine equipment up there in the air. This is the Nelsus right here. And that's where all your components, the gearbox, the high speed and the low speed shaft are located. This is an anemometer, which senses the wind's direction and speed, and it actually turns that whole thing, the Nelsus, not the tire, just the top of piece where the blades are connected at the rotor hub. It actually turns around 360 degrees all the way. And I'll tell you, I'd hate to be in it if it ran away, because it usually normally cuts the tower in half at the same place every time. They cut off at 35 miles an hour. When you're driving by a wind turbine field, or wind farm as we call them in the industry, you'll see them turning and you'll think, man, that thing is moving slow. But that's a 150-foot blade times squared is 300, so you got a 300-foot radius up there spinning 35 to 38 miles an hour at top speed. And I mean, it's torquing out. So then we move on into the present there, and now the future. wind turbines. Poor Junior, he yelled out, "Holy cow," as he stepped atop the Nelsius. He says, "It wasn't even snowing when we started climbing." And he looked over, his wind training mentor looked over at him, and he said, "Well, Wind Cowboy, welcome to the new generation of the wind turbine fields." And then Charles Brush come down and touched him. Didn't have to go very far because they were so high. It's predicted to be 985 feet by 2020, and even higher by 2050. And those sources all come from the EER alerts, which is energy, the Department of Energy, governmental alerts. And I get those, I've been receiving those for 2 years now. I've been receiving those. I've read over 580 of them. I've been attending school here and almost completed all my wind tech classes for 2 years. I've also worked in the electrical energy of the distribution part of pole line construction off and on for the last 8 years. I worked in the oil field as an electrical technician for Bloom Electric for 2 years when I was 14 till I was 16. And so I've been in the electrical industry a long time. And my other sources were all online research of this wind Department of Energy catalog. It's a magazine that they produce. It's not even a catalog, it's a published magazine that they produce now. And it was called The Future of Wind Turbines, page number 7. That's all in my papers there. But that's all I got.